All right, for compounds, we've looked at two types of compounds. We've had ionic compounds, and those involved a metal and a non-metal. So if we look at something and we see a metal and a non-metal, that will form an ionic bond. Oops, squeeze it in there, sorry. And along with the ionic bond, another thing, we had polyatomic. Those were also ionic bonds. So if they had more than two elements, if they weren't binary, meaning two, if there were three or more, that was polyatomic, and that is also an ionic compound. And then yesterday we looked at molecular compounds. Molecular compounds, covalent, binary molecular, those all things mean the same thing. Now what you're looking for here with molecular is you actually have two non-metals bonded together. So if you had two non-metals bonded together, that's a molecular compound. Or in some cases, it may be the same non-metal bonded with itself. We saw 7 of those that could happen in that lesson. All right, so today what we're going to do, instead of separating them out, I just want to do a couple of quick examples of mixed formulas or mixed names. So we have to determine what type of compound it is and then follow the rules for each specific compound. So let's just try a few mixed ones. All right, so let's start with a pretty straightforward one. We'll go NaCl. So what is this going to be called? So first thing to note, you have to pick out what type of bond we have. Na is a metal. Cl is a non-metal, and that's just how I'm going to abbreviate them from now on. So a metal and a non-metal, this is an ionic compound. We're going to use our rules for ionic bonds. And the rules say, when we're naming, name the metal. Na is sodium. Then name the nonmetal. This is chlorine, but we change the ending to chloride. Now double check that metal, Na. There is only one combining capacity. It is +1, so we don't need anything else. Sodium chloride, we're done. Okay, move that up. How about MnS? So I look, Mn is a metal. S is a non-metal. So once again, this is ionic. So I name my metal first. Mn is manganese. And S, name the nonmetal, sulfur. I change that to sulfide. Now I left a little gap here because when I found Mn, I actually saw +2 and +7 as the combining capacities. So I'm going to need some Roman numerals. Let's figure out what those Roman numerals are. I'm going to slide this up, and I'm going to do a reverse crossover here to figure out my Roman numerals. So I'm just going to move this down here, MnS. It looks like 1 and 1. So I'm going to reverse. This 1 goes up here. This 1 here is up here. Now, manganese 1 is actually not an option. It was 2 or 7. But if I look closer at sulfur, sulfur should have been 2. So I'm going to actually have to multiply by 2 to get the combining capacity for sulfur. And I'm going to multiply this side by 2 as well. So now that becomes Mn with a 2, and sulfur has its 2. So the combining capacity, and therefore the Roman numerals, 2. So MnS, manganese 2 sulfide. Let's keep going. Let's try another one. I'm going to have CO2. Now we've seen this one a number of times if we remember back to our ecology unit. C is carbon, that's a nonmetal. O is a nonmetal. So this is a molecular compound or a covalent bond. Okay. All right, so what are the rules for this one? Well, this one says name the first element in our formula. So C is carbon. Name the second element. That is oxygen. We're going to change that to oxide. Now, because it's molecular, we need prefixes. So that 2 becomes dioxide. There's only one carbon, but because it's first, we don't use mono. We just say carbon dioxide. And that matches up with our ecology unit that we've seen before. All right, let's do another one. Let's say we have Fe2O3. Fe is a metal, that is iron. O is a nonmetal. Okay, we're back to an ionic bond. So I name the metal first, iron. Now when I notice iron, I actually see +2 and +3 here. So I'm going to leave a little gap, then I'm going to name my oxygen is oxide. It's ionic, no prefixes here, just name them each, but we do need Roman numerals. So I'm going to go through my reverse crossover again, just down here in the corner, Fe2O3. I'm going to reverse that, so the 2 moves up here with the oxygen, the 3 moves up here with the iron. I go to my periodic table. Oxygen is supposed to be +2, so I don't have to change anything. Like a little bit before we had to multiply, I don't have to here. Oxygen is -2, sorry. So this is iron 3, so I need iron 3 oxide. Okay, how about N2O5? N is a nonmetal. That is nitrogen. O, nonmetal. 2 nonmetals. This is a molecular compound. So I name the first element, nitrogen, and the second one, oxide. But molecular compounds need prefixes. If it's molecular, I'm going to put in my prefixes. There are 2 nitrogens. Dinitrogen. There are 5 oxygens. Pentoxide. Now, if you say pent or pentaoxide, they're okay. Dinitrogen pentoxide. We'll go one more. All right, so now let's try NH4Cl. Okay, well, the first thing I look for here is I have 1, 2, 3 capital letters. So this can only be polyatomic, and polyatomic is ionic. This is an ionic bond. Okay, so now I have to find which one is the polyatomic ion. Now normally brackets could help us. That identifies the polyatomic ion. The majority of them are the last elements, but there is no Cl on my polyatomic chart, but there is NH4. So NH4 is my polyatomic ion. So I'm going to my chart, I find NH4, that is ammonium. Okay, no prefixes, this is ionic, so no prefixes. Ammonium, I name Cl, that is chlorine, and we change the ending to chloride. This is ammonium chloride. Now I said that was the last one. I want to try one more. What if we had Br2? So now we only have one capital letter. There's only one term here. It is one element bonded with itself. Now I do know that Br is a nonmetal. Some nonmetals can bond with themselves. This is called, not binary, this is diatomic. So we had polyatomic, many atoms. This is diatomic, there are two atoms of the same element. So this is diatomic, and all of these are molecular. These are nonmetals that are bonded with each other. So we actually have a special way of naming them. Now there are two of them, so if we went and said dibromide, I mean, it's technically true, there are two bromides bonded together, but usually if we have any of these seven, and we can remember them with that Hofbrinkel the clown we had before, if there's any of those seven, we call them by the element bromine, and then we add gas. This is bromine gas. So that's a special one. All right, try those out. Keep practicing. This is really just a little bit of practice to round out all these naming and writing formulas for these things.